Cool. So before we get started with our presentation, I just want to give you guys a little bit of background on who we are as a team. We have a very diverse skill set. We come from operations, the petroleum industry, finance, and retail. And with all the events that have been happening seismically, say in Mexico, we're kind of interested in what the seismic effects were in the United States. So what is the impact of seismic activity? Now, if you guys are from the East Coast like myself, never been in an earthquake, you probably think it's something like this. But so we did a deep dive on our data, and actually it's more like this. So this is just the past 30 days of what we have encountered seismically off USGS. That's the United States Geological Survey. It's clustered in Oklahoma, little clusters it on the west coast. And here we have fault lines. So, but this is actually a heat map of where you're most likely to have seismic activity across the board. So, USGS, that's where we pulled most of our data from. Initially, that was just the backbone of our project. We were able to pull data from 1900 forward. We appended that with Baker Hughes. That data is data that has drilling rigs and whatnot from the petroleum industry nationwide. What, from 1960 forward?
Yes, correct.
All right.
Freely available.
Free. I like free. Okay, so we also got another free site, Zillow, for home prices, and that goes for both rental and ownership. And last but not least, US Census. So, all right, so what did we get from the USGS? They actually have a really cool API. It's free, keyless, no limit. So we got 130,000 lines of data, over 36 columns, including calculated fields. And it was data from 1900 to the present, as I had initially stated. So how long did that take us to get it? It sounds like a lot. You're forever and a day. 3 minutes. So. All right, so how did we do this? And, oh, yeah, I will keep it brief. So, just a real quick high level here. You know, we called our dependencies, did this in Jupyter. We created our lists, most of them we didn't use. We calculated our fields right here. We appended our data. You can actually pull 20,000 records at a time with the USGS. So back when there was less data, we could have pulled a longer range, but as you get closer to the present time, there's more and more data available, so you're probably going to get only about 5 years worth of data in one pull, which isn't too bad, but we calculated that up in this area here. Not going to bore you with the details. I'm keeping it brief, I promised. All right, so we've got our appendix or appendings, and here's our data frame, and blah, 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 all the good stuff. So, oh, 1 second. So, I said I was going to keep it brief. So, what did the data tell us? So, over here, it almost looks like, so we have, in red over here, we have the average magnitude year over year, and we have, in the blue, we have seismic activity count. So it seems like the more counts we have, the higher count we have, it's like our data's flattening out. Almost like we're getting not as much seismic activity as we really would have thought. Now, that's kind of funny because we keep on hearing in the news about, hey, there's more seismic activity going on. So what's really going on here? So perhaps we need to take a different perspective. So here we forgot about the averages, and we just plotted seismic activity by the magnitude year over year, but something looked a little weird here. So I'll give you a hint. Anyone? No? There's an insufficient amount of data prior to the 1930s. So as we saw back in, let's see, this slide, we saw a higher magnitude because there's just less data, and it normalized as you went forward. So that's the big picture. I'm going to turn it over to Jeff, and he's going to drill down into more of the details.
Drill down, I like that. All right, we're going to dive deeper. I've got some spoiler alerts that pertain to Fervis's section, so I apologize, but you might get some of it a little early. First, we're going to look at the earthquakes. Now, John's right that over a long enough period of time, the earthquakes do average out. And what I started looking at was 2000 to 2017. More importantly, average of magnitude and the count of the earthquakes per year. And these are in the states California, Nevada, Oklahoma, and Washington. And Oklahoma stood out as an outlier whenever we were exploring it. They're having significantly more earthquakes, and the earthquakes are significantly stronger. It goes from 2.6 to about 2.85 average. Since that's a logarithmic Richter scale, it's 25 times stronger, which is pretty fascinating. So, is this related to drilling rigs in the area? So I went to Baker Hughes and I pulled their free data, started putting it into our Jupyter notebook, using Seaborn, trying to plot it. And the time scale on this is from January 2000 until December 2013. And over that time, this is the rig count per month in the United States, and we've been seeing increases. It actually correlates with the earthquake data that we've seen. If we look at Oklahoma individually or Texas individually, they're both having more earthquakes. They're having more frequent earthquakes. Or, I'm sorry, more frequent earthquakes. They're having stronger earthquakes, and they have more rigs drilling. And I think that's going to take us to the chicken or the egg correlation causation argument. But, Fervis, I think I'm ready to.
All right.
Where's Gordon? You need to talk about why we looked at that.
So thanks, Jeff. So you've seen so far some of the data exploration that we've done and some of the trends and high-level earthquake snapshots across the U.S. Now we want to take that further and do some analysis in terms of what the impact of this economically, right? So the first question here is, what is the impact of the 2013 light to moderate magnitude earthquakes to the city's per capita income, right? Before we get into the analysis, I just want to walk you through, the basic metrics that we use here. This is a distribution of earthquakes over the last, for 5 years from 2011 to 2015. As you can see here, there's not a lot of earthquakes that has significant, seismic or magnitude, right? Seismic 2 and 3 may not have much impact practically. So we want to focus our analysis on seismic 4 and above, okay? In that way we can see some, meaningful impact to the population that we're trying to analyze, okay? As you can see, the graph, it's very much leaning towards, low magnitude earthquakes. That's going to give you a comparison in terms of the sample that we will be dealing with. We're going to be dealing with the magnitude 4 and up, which is way, not a lot compared to the other magnitudes, okay? So going forward with our analysis, we picked 2013 as the subject of analysis. Oh, sorry. The population that we pick are zip codes that were impacted by the 2013 earthquakes with a magnitude of 4 and up, okay? And we have the magnitude effects here, bucketed into these categories, right? As you can see, we only have light to moderate earthquakes to analyze here, which is fine. Looking at the demographics of the impacted zip codes, the population ranges from 11,000 to 50,000 people within those zip codes, right? So this is our subject for analysis, and the data that we have, there's not a lot of zip codes impacted. We have about 19 zip codes who experience those light to moderate earthquakes for that year. Per capita income is calculated by, looking at 2013 per capita income less 2012 over, the previous year's per capita. Okay, so we're trying to see how much of a drop or increase, in per capita income, before the year before the earthquake and when the earthquake happened. Okay? And what we saw is there's an average increase of, there's a drop of negative 1.05% across all the population. Okay? So that's our hypothesis. Based on this analysis, we have a decrease in per capita income. Okay? And looking at the distribution of, the decrease, you will see we have a good, distribution of locations here, not just focused on California, but different areas in the U.S. All right. So to test our hypothesis, did that earthquake really impacted or cause a decline in per capita income? So we took some samples of 1,000 zip codes across the U.S. and look at their distribution by change in per capita income. So we have a pretty much normal distribution as a control. And then we look at, based on the control that we have in the subject or the alpha, which is the 19 zip codes, we ran that through our hypothesis test using t-test, and we came up with a very positive outcome. That means that, at least for the earthquake in 2013, it has caused an impact on the per capita income of the population we're trying to analyze. Okay. Taking this further and looking at the impact of that in employment, particularly in the natural resources and construction industry, did it increase employment when the earthquake happened going into the following year, right? Again, we used the same sample using the same 16 zip codes. We saw that there's an increase of 1.93% employment rate the following year after the earthquake. Running that through this is the distribution of increase or decrease of employment across all the zip codes that we have. Running that across our t-test, we have, again, same population. We did this in multiple iteration, changing our samples across the US to make sure that that analysis will hold, right? And same thing we did for the per capita income. For this metric, though, what we saw was the earthquake didn't make any significant impact on the increase of employment, particularly in those areas that has to do with geographic or economies that may have increased for a major earthquake and things like that. Natural resources and construction. But in this case, the earthquake shows that it didn't, which makes sense because we're just looking at light to moderate earthquake. There's really no significant infrastructure damages, things like that, that may spur employment in the construction industry the following year. Okay? So that's kind of like our conclusion for these two metrics as far as how they impacted, they're impacted with these seismic events. Okay? And Ed will do
I'm just going to follow up on this. Basically, the journey that we took throughout this discussion process is we formulated the questions at a high level. What is the impact of seismic activity? We identified the three sources, which was Baker Hughes, Zillow, US Geological Surveys, and American Census Bureau. The data preparation and cleaning, the data exploration, the developed model, and finally the conclusion that you saw today. The other economic impact that we'd like to further analyze is the if the analysis can happen other years to determine if the case observed in 2013 happens on other years, such as 2014, 15, 16, and also the home prices. The challenges that we faced in this discussion was unique to EPCOP time. Those who don't know what EPCOP or EPCOP time is, the Unix time that was started in January 1st, 1970, which basically counted the seconds from then to now. This was a unique data formatting issue because it tied in all of our data sets through multiple data sources. Secondly, the data visualization. John and I stumbled across, actually John stumbled across, and we had an interesting conversation along this, was, are earthquakes seasonal? We found out this question because we asked, John thought to look at the graph at a cyclical process. And we kind of saw a trend, and that was one of the main questions that came up in the data visualization aspect. Some of the key takeaways: chicken or the egg? Are earthquakes being due to oil rig industry or seismic area prone targets of the petroleum industry? Data is getting better on every day with correlation to seismic activity. Although the data is flattening over time across the United States, certain states are seeing peaks where other states are seeing valleys. As Jeff mentioned, Oklahoma was one of those big outliers. And lastly, economic impact. Based on the subject, 2013 subject, we saw multiple samples and iterations analysis that shows light to moderate seismic activities cause a decline in per capita income. Thank you.
All right, let's do 2 minutes of questions.
I have. So you kept going back to the chicken and egg. That's based on your 2013 data, right? Is that what you looked at?
Say that one more time.
So whenever you said chicken and egg, because you said, the question really is was there actually, did you look at when the rig operations actually started in these two states, Oklahoma and I think?
Yeah, so we looked at from 2000 to the end of 2013,
Right.
month by month, and the count, and then watched it go up.
Were the rigs actually started then? So basically the question is, because you were trying to get to that, right? Did the earthquake increase because of the persons of seismic activity increase because of the rig, right? But when did the rigs start digging into those locations, or?
We'd have the data back till 1960, but that's in PDF form for a couple of decades, so it's very difficult to get. But I think one thing that would be interesting to explore further is the development of fracking
Right.
in like 2002.
Yeah, I think it's interesting to see the earthquake it started when the drilling started.
Sorry.
What we did, the earthquake started when the drilling started. What we did is we didn't look at a timeline, but we look at a certain set of year, regardless when they started the drilling, and see if there is like a recurring impact, right, on earthquakes.
Yeah, and if you look at it at the USA level, everything's flattening out. We have you can just keep that one. Everything's flattening out, and being that we have data from 1960, like back to 1900 here, 1960 data that Jeff has, and we focus on the 2000 forward seismic or increased drilling versus seismic activity. It looks pretty flat, so one would say, yeah, there's probably none. However, we uncovered, or actually Jeff uncovered a study that was based off of, I think, Oklahoma, where it wasn't the actual drilling that was potentially causing the earthquake spikes. It was taking the drill water and pumping it back into the ground.
Yeah, and they think that it might be that the water they used when they were drilling that they dispose of.
Yeah.
So could dig into it a lot further. Could
Yeah.
also see if it dropped off at all whenever oil price dropped.
Yeah, but the takeaway is that you really can't look at it at a national level. You really have to do it state by state.
I've got a question. So you pointed out that this is flatlining from a magnitude perspective.
From an average magnitude perspective.
But when I look at the activity count, it does look like it's going up. What's your thought on that?
Well, the average magnitude is flattening, the red.
But let's
So
say-
the takeaway from that is that one assumption that we could take away from that is that it's going down because we're getting more data and we're catching the little guys. We're not only catching the big magnitude earthquakes that we see over on the left over here. As we go right, we get more of a count, so you're catching your smaller seismic activities, and the overall average flattens out and decreases.
So you're saying that on the average, the activity count, you're dismissing it because you're saying that there's more mini.
Well, we're not dismissing it.
Yeah.
We're just pointing it out. Because when we look at it at a state-by-state level, we still do see peaks and valleys, and those peaks are think, what was it, in Oklahoma, it was like 20% or 15% over 5 or 6 years? No, I think it's something greater than that.
Yeah, it was a huge increase.
Yeah.
Another thing that I did want to explore, didn't have time, 1950-ish, there's a little blip on the activity. I want to see if it correlates with atomic bomb testing.
What is it called?
Because it'd be interesting.
Atomic bomb.
See if it correlates to the
I see.
bomb testing. But,
Mark, you have a question?
I was just going to elaborate a little more on what you guys were talking about before, about the correlation between rig count and seismic activity or intensity of the seismic activity. Rig count is probably highly correlated to the price of a barrel of oil and the price that it takes to get that barrel of oil out of the ground. And fracking actually reduces the price to get that barrel of oil by injecting the chemicals with the water. So it's going to be hard to discern the rig count from the fracking and which one's actually causing the
It
seismic
could be other
activity.
factors.
Plus the
yeah.
confounding
Yeah.
factor of if the pumping the fluid back in, that
Yeah.
just.
Yeah.
That's something that we want to run like a hypothesis test and see if it's really, the one
Yeah,
that's causing
yeah,
it.
so
That
it
would
could
be
be
a good
cool.
subject, but.
Yeah, this is
There
really
are-
only the tip of the iceberg. I mean, we found ourselves with so much data that one of our challenges was which direction do we go? I mean, we got this huge data set. So we picked and chose. We couldn't pick them all in 2 weeks, but on the whole, I think we have a great direction and can probably take it a lot further.
All right, thanks again, guys.